Hi, welcome to Computing Foundations, a channel for beginners who want to learn about programming, computers, and the math, science, and art behind this world-changing field. I'm Josh Kilpatrick, a retired software engineer. In this video, we're going over the solution to the Programming Challenge 11. So our challenge here was to write a function that will print out a nice mapping of memory that looks like what I've highlighted here on the screen. The way we defined the function was we named it printMem, and it takes in as an argument an integer array and an integer that represents the size of that integer array. So let's first look at the main function so that everybody understands what I'm doing to run the program. I create an integer array of size. Size is a constant that I defined, which is 20 integers. I define the constant at the top of the file. It's best practice. I initialize a random number generator, and then I loop through each element of the array, assigning a random number. I just wanted to have an integer value in the memory. I didn't care what the value was. And so I used this for loop and generated random numbers. Finally, I call the printMem function. I pass in the array by simply giving the name of the array and the size by referring to the constant. So this is my main function. Let's take a look at the printMem. So the first thing I do in the first line, 39, is I print out my header. And the way I figured out, how to space this was just some trial and error and counting characters. So, it's not that important that your table be perfectly aligned, but this will align everything with a nice header at the top of the file. Next, I print a line that represents the top of my memory table. And then I begin. I loop through the integer array based on the size that was passed into the function. And here's what I do. For the element that I'm looking at, so I'm going to look at the array one element at a time. First, I'm going to define a pointer that holds the address of that element. So when I'm doing the first loop, I will be equal to 0, and I'm going to get a pointer to that first element of the array. Now, why do I define a unsigned character pointer? Okay, remember that a character refers to 1 byte. But if I just define a character, I'm going to assume that it's a signed character, meaning it can only represent values up to 128, not all the way up to the complete highest value that can be represented by 8 bits. So if I want to dereference memory 1 byte at a time and see what's inside that byte, ignoring the idea that it might have a sign, a plus or minus, because that's not how the memory is organized, I need to use an unsigned character. Otherwise, if the value represented by the 8 bytes is greater than 128, the computer is going to assume I'm referring to a negative value, and I'm not going to really get printed out to the screen what's in the memory location in full. And that's just because of the way signed integers work in binary. So I need to get an unsigned character pointer. Then I go through and dereference that pointer so that I have in a variable the actual value stored in each 8-bit 1 byte block of memory for this integer. So I'm going to have 4 bytes. The byte in the first address, the byte in the second address, the third address, and the fourth address. All right, now it's time to print everything out to the screen. So the first thing I print out is I, the index of the array, and I pad it with 3 zeros, or I make sure it's 3 digits wide just to make everything line up. Next, I print out the value that is stored in a sub I. And as I mentioned to you when I described the programming challenge, I used the format character %x, which means print this out in hexadecimal format. Again, I did that so that we can see very clearly how this is being represented in memory, how this integer is being represented in memory. Now finally, next, I print out the pointer address, the address of the current index, okay? And then I print out each byte in hexadecimal format with only 2 digits. So let's run this program and see what happens. All right, so I've just compiled it, and now here we go. I'm going to run it. Oh, I compiled the wrong program. Let me try that one more time. I compiled the program. All right. I compiled the example program for the lesson instead of compiling the challenge. All right, so here's what the output looks like. In index 0, I have stored this random integer. As I look at the address, it ends in 468. You can see here the next address for the next element begins 46C. Why is that? Well, 8 plus 4 is 12, and the way you represent 12 in hexadecimal is a C. A, B, C. A is 11. Sorry. A is 10. B is 11. C is 12. And then I print out each byte, and you can see here that the bytes don't make any sense. Oh, sorry. I was looking at the address instead of looking at the memory location. So we see here byte 1, 1A, is the least significant bit of the memory location. Byte 2, A6, is the second most significant bit. Byte 3 is here, and byte 4 is finally here at the end. So that's the programming challenge. I hope this exercise of looking at pointer arithmetic has helped you get a clear understanding of arrays and pointers, how they're related to each other, and how pointer arithmetic is a smart kind of arithmetic where the computer advances the pointer to the next memory address based on the type of pointer that you've declared. If you didn't solve the program, as always, don't stress. The only goal here is to struggle and to learn. Some of these programs are intended to be a little challenging, and the goal is that you would struggle a little bit with the concepts so that when you do see the answers, it forms more strongly in your mind what you were doing wrong and what the right way to program the solution is. All right, we'll see you next time.